Figure given below shows a square loop of side 5 cm being moved towards the right at a constant speed of 1 cm per second. The front edge enters the 20 cm wide magnetic field at t equal to 0 second. Find the EMF induced in the loop at t equal to 2 second, t equals 10 second, t equals 22 second and t equals 30 seconds respectively. So if I draw enlarged view of this arrangement, so we can consider it in this way, that this is the region of magnetic field which the problem is talking about, which is 20 centimeter wide. So this region is 20 centimeter wide, and the square loop which is entering into this region is initially located at this junction, having a side length of 5 centimeter. So it is having a side length of 5 centimeter. Now I calculate the different distance which it is going to cover in the respective time. So in 2 second time, so we are calculating the distances associated with these time. So I'm saying that the distance which the front part of the loop is going to cover is equal to 1 into 2, that is 2 centimeter. The distance which the front part of the loop is going to cover in this case is 10 into 2, which is equal to 20 centimeter. The distance which the front part of the loop is going to cover is 22 into 1. Over here also it will be 1. The speed associated over here is 1 centimeter per second. So it will be written as 10 into 1, that is 10 centimeter. This will be 22 into 1, that is 22 centimeter. And over here in the fourth case or the D case, it is 30 into 1, that is 30 centimeter. So at t equal to 0, this is the picture how it is looking like. Now at t equal to 2 second, this diagram is going to change in this way, that this loop will get introduced into this frame by a distance of 2 centimeter. So the front part will cover a distance equal to 2 centimeter in 2 second, and this is going to be the area which is introduced into the magnetic field now. So the flux change is associated with this red shaded area which we have marked over here in the figure at t equal to 2 second. Now at 10 second, the entire square loop has entered the region of magnetic field, and there is no flux change associated at this point of time. So there is no flux change that is taking place. So the value of EMF induced at t equal to 10 second will be 0, because there is no flux change that is going to take place. And in the first part we have calculated this distance to be equal to 2 centimeter, which is introduced in the region of magnetic field. So the area is effectively 10 centimeter square. Now at 22 second, this frame is going to be looking like this. The front part covered a distance of 22 centimeter, so that is it is moved out from the region of magnetic field by a distance of 2 centimeters. So this is the distance that it moved out. So the complete width is 20 centimeter, and it covered a distance of 22 centimeter, the front part. So it has moved out by a distance of 2 centimeter over here. So this is 2 and this one is 5. So I can say that the area associated with flux change in part A and C is same. In part A and C, the area associated with flux change is same. And in the last part at t equal to 30 second, again the entire loop will move out of the region of magnetic field, and it will move out of the region of magnetic field. So there is no change in magnetic flux taking place at this instant of time. So the EMF induced at 30 second is also going to be 0. So these two answers we have made out that the value is going to be 0 for B and D. There will be no flux change associated with the coil at these two instant of time. So the value of EMF induced at 10 second and 30 second will be 0, and at A and C, that is at 2 second and 22 second, the area linked with the flux change is same. So the EMF induced is going to be same, so we are making a single set of calculation for A and C. So the area which is changing is equal to 2 into 5, that is 10 centimeter square. So we can convert it into meter square. So we have 10 centimeter square. So we can write it as 10 upon 10 to the power 4 of meter square. And the value of magnetic field which it enters is equal to 0.6 Tesla. And the change is taking place in both case in 2-second duration. The effective time is going to be 2 seconds, because at 22-second point till 20 second the value of flux change will become 0, and this area is introduced out of the magnetic field in 2-second time. So we will take the effective time as 2 seconds. So over here, if I write the magnitude of EMF induced, so the magnitude of EMF induced is equal to change in flux divided by time taken. So we can write it in this way, that the change in flux is going to be B into area 1 upon 10 to the power 3 upon time taken, which is equal to 2 seconds, and the value come out to be 3 into 10 to the power minus 4 volt. So the value of EMF induced at t equal to 2 second is 3 into 10 to the power minus 4 volt, and at t equal to 22 second is also 3 into 10 to the power minus 4 volt, and at B and D, that is 10 second and 30 second, there is no EMF induced.